students, you are on to Dr. OJ tutorial class. In this video, there shall be a special tutorial review on topics we have learned so far. Stay blessed as you watch. Now we have example 1 that says find the range of y is equal to absolute value of x minus 1 plus absolute value of x plus 1. Now, we recall the definition of absolute value that says that the absolute value of x, for example, is going to be x, if x is greater than 0, it will be minus x if x is less than 1, or if x is less than 0, if x is less than 0. That is the definition of absolute value of x. Now, we will need to find the absolute value of x minus 1 and absolute value of x plus 1 respectively, add them together to find the range that we had to find. Okay, let's start with this. Let's start with this. Absolute value of x minus 1 is defined as x minus 1. It's going to be x minus 1. Let me use this curly bracket, or this step bracket. If x is greater than or equals to 1, you are wondering, how did I get this? Fine. If you equate x minus 1 to 0, x minus 1 equals to 0, x will be equals to 1. Now, for this absolute value to be what? For this property to be retained, if x is 1, because this statement means x is equals to 1 and x is more than 1. So if x is 1, 1 minus 1 will be 0, which is okay, because 0 is positive. So this is talking about the positive side of the absolute value. Okay? Now, for the negative side, if x is minus 1, now, we say that if x is, so it is will be minus into x minus 1 if x is less than this 1. How? Like I said before, I said that x minus 1, if you equate it to 0, you have x equals to 1. So that is what gives us the idea of the 1 we use here. And we are using greater than or equal to 1 because we want a positive value for the first one here. If x is 1, 1 minus 1 will be 0, which is positive. If x is more than 1, that will be, let's say 2 minus 1 is positive 2. So for the first one, we have a positive value. Now, for the second one here, if since from our previous definition, the one I showed us previously, I said the absolute value of x, is equal to x if x is greater than 0, is equal to minus x if x is less than 0. So the concept of less than is used here, and because we said minus x, the absolute value of x is equal to minus x if this is happening. So that means minus this value, okay, if x is less than 1. The 1 here is when you equate x minus 1 to 0, you have 1, like I explained here. So we define this from this concept. Okay, now let's look at the second one. X plus 1. Fine. X plus 1, the absolute value of x plus 1. Okay, now it will be x plus 1 if, let's equate x plus 1 to 0. So x equals to minus 1. So in this case, we have minus 1. Okay, now for this, it will be minus x plus 1 if x is less than minus 1. So that is the definition for the absolute value of x plus 1. Okay, now going by what we are given, we are expected to get the addition of this and find the range. So we need to find the critical values now. The critical values now are, the critical values are 1, x less than minus 1. 2, this one is previously we said that, let me quickly rewrite what I wrote before. The absolute value of x minus 1, so for remembrance, is x minus 1 if x greater than or equals to 1, is minus into x minus 1 if x less than 1. So now if we want to combine that, we could have, we picked what? We picked minus s less than minus 1. So we can equally have, if we twist this one, if we write this one, it could be minus 1 less than equals to x than s less than 1. We have combined this and this together. And the last one, this, it will also be x greater than or equals to 1. These are the critical values of our x. Critical values of x are, again, this, we have x is less than minus 1. We pick that. Then we combine this and this together. So if we write this, it will be minus 1 less than or equals to x. Minus 1 less than or equals to x. Then x less than 1. And the last one there, s greater than or equal to 1. Now, having written that, we have gotten our critical value. So we now examine the critical value one by one with respect to the absolute value of x minus 1 and absolute value of x plus 1. Let's use our critical values one by one. Now the first one, for x, when x is less than, is it 1 or 2? Minus 1, okay? When x less than minus 1, I think we will need to quickly write this thing. Let me x plus 1 also. Let's write it so that it will be easy for us to remember. X plus 1 if x is greater than or equals to minus 1 minus x plus 1 if x is less than minus 1. I think that's what we have in our notes. I think that's what we have in our notes. I think that's what we have in our what we have just done. Fine. So when x is less than minus 1, so y will be absolute value of x minus 1 plus absolute value of x plus 1. So what do we have there? Okay, let's look at where we have x less than minus 1. We have this. X less than minus 1. It happens there. Fine. Okay, it happens there. It happens at minus x plus 1. And it also happens there. Because when we say x less than minus 1, less than here is happening here. Less than is happening here. So in that case now, and when we say less than minus 1, it could be minus 2. And minus 2 is less than 1 here. So we can pick this. So picking this means what? Because we are talking about x minus 1, we start with x minus 1. Absolute value of x minus 1 here is suitable for this, is correct for this, but not for this. The absolute value of x plus 1 is correct for this. Yes, not for the first one. So this one will be what? It will be minus into x minus 1 for the first one, then the next one, the minus into x plus 1. Yes. So that will give us what? Minus x plus 1 minus x plus 1. So this will cancel. Okay. So, sorry, this is minus 1. We are expanding. Come on. So this will cancel this. So we have minus 2x. That means when x is less than minus 1, considering the value given to you, absolute value of x minus 1, it's suitable for this. This satisfies that condition. S plus 1, absolute value of s plus 1, this satisfies that condition. So you write out the values. That's what we have done. Now, the next one, when x, let's look at the next one. The next one says when minus 1 less than equals to x less than 1. So y will be equal to x minus 1 plus absolute value of s plus 1. Let's look at what that one goes for. Now, we can start with x less than 1. X minus 1, absolute value of x minus 1, what does it give us? X minus 1 gives us this. Yes, because the absolute value of x minus 1, while x is less than 1. We have this. So we can write this as minus x into minus 1. Okay, then plus, when consider absolute value of x plus 1, this one, for you not consider the other one, because s, this one is like x greater than or equals to minus 1. So we have it here. It's suitable for this one, this upper one, x plus 1. Please don't get confused. Again, we are considering another critical value. This one we have written out. We can start with this. We can start, but because the y value is starting from it's starting with absolute value of x minus 1. So you go to x minus 1. Where do you see x less than 1 in this condition? The x less than 1 is in this condition. Is this the argument here is for this? So that means this whole thing will be taken as the argument for absolute value of x minus 1. Then plus x plus 1, absolute value of x plus 1. Look at it. Where do we have the other one? The other one for this now is x greater than or equals to minus 1. Okay? Now, where do we see x greater than or equals to minus 1? It's on top. The one on top. So x plus 1 is there. So you write it. That's how to do it. So now have what? When you open this one, you have minus x plus 1 plus x plus 1. So minus x will cancel plus x. So you have 2. Okay? I think you have 2. Now the last one. The last one. Let's look at what is suitable for the last one. When x greater than or equal to 1, fine. Then y is equal to absolute of x minus 1 plus x plus 1. Let's check which of the argument is suitable. Now when x is greater than or equals to 1 for x minus 1, we have this. Because x greater than or equals to 1 for x minus 1. This is the argument. So we have what? It will be x minus 1 plus. Now when the absolute value of x plus 1, when x is greater than or equals to 1, x plus 1, x greater than or equals to 1. Okay, we have this. This one also. Why? Why? Because now when we say x greater than or equals to 1, it means x could be more than 1. So if I pick 2, 2 is more than 1. If I also pick 2 here, 2 is more than minus 1. So this is suitable for it. So we have x plus 1. You can't pick this one because it's less than, not greater than, equal to. So this will cancel this. So you have what? 2x. Okay? Now, the range, therefore the range of y is equal to x, absolute value of x minus 1 plus absolute value of x plus 1 will now be a set. You know, the range is the set of y values, output values. So we are looking for y. That will be what? That will be y, that is set y such that y is greater than or equal to 2. So you can look at this 2. 2 is the value there. Why do we pick 2? You know, in the first one we have 2x or 2. Is it 2? Minus 2x. The second one we have 2. And the third one we have 2x. So if you assume that your x should be, let's say 1 now. This one will be minus 2, 2, 2. So the range is between minus 2 and 2. So which invariably means, what if x is minus 1? Everything will be, this one will be minus 2, 1, 2. It will still range, it will still be between minus 2 and 2. So in other words now, invariably, we are moving towards the right. The range is increasing along the positive y. So it will now be what? And not only that, our constant, the value we obtain as our constant is 2. So that means the range is greater than or equal to, start from 2 and moving forward. So that is that about that. So now look at the second question. We are still talking about what? The tutorial review. This is a special class, it's a special video to revise or to review what we have learned so far in this particular period. Okay. Now the second question, evaluate. This is coming from limit theory. Evaluate limit as x tends to infinity of x plus sine x all over x. Now, yes, that is the question. Now this question, if you look at it, is a very technical but simple question, only if you know how to apply the solution to the problem. Now, you cannot apply x tends to infinity directly. You just have to make use of some technical solution. And this one, if you look at it holistically, what is suitable for this kind of question is what we call squeeze theorem. I call it what? Squeeze theorem. We can apply squeeze theorem. Squeeze theorem. Why do we want to apply squeeze theorem? Because it's talking about the boundedness of x. If you look at it holistically, x is bounded. X is bounded, but that is particularly x plus sine x is, you know, sine x is, let's say, note, Note, sine x is bounded between -1 and 1. That is -1 less than or equal to sine x less than or equal to 1. Yes. That is any value of sine x. -1 is always less than or equal to that value, and it's equal to. So the range of sine x, that is the plot. You are plotting the graph of sine x. Sine x is going to be, you have -1 here, +1 here. So the range is always between, this, something like that, sine x. So it's bounded, and Squeez's theorem is talking about the boundedness of a function, particularly trigonometric function. Okay, so with this now, we can now continue with the operation of finding the limits. We have said now that sine x is bounded between -1 and 1. So let's assume that we had x to all the sides, adding x throughout, adding x to the equation becomes, when you add x to them, becomes what? Let us use this, please. Let's use this, please. Adding x to, that is what? You have what? X minus 1 less or equal to x plus sine x less or equal to x plus 1. Beautiful. And we have added x to this particular bounds. Now, in order to arrive at x as a denominator, let's divide through. Now, dividing through by x gives x minus 1 all over x less than equal to x plus sine x all over x less than equals to x plus 1 all over x. You see now that the function in the middle is now this particular value that we have to find. So that means that this value x plus sine x all over x is bounded by x minus 1 over x and x plus 1 over x. So what we need to do now we find the limits. Now we find the limits of the boundary, limit of the boundaries, of the bounds. It is limit as x tends to infinity of x minus 1 over x, and limit as x tends to infinity of x plus 1 all over x. So let's try and find the limit. Let's try and find the limit of this. So we have, for the first one, how about limit as x tends to infinity, x minus 1 over x. This can be written as x, we can write this as taking the limit x over x minus 1 over x. That is finding the limit of as x tends to infinity, which is going to be what? 1 minus 1 over x. So we want to find the limit of x tends to infinity of 1 minus, we can rewrite x minus 1 over x as this. All right. So now, taking the limits of this 1 minus 1 over x as x tends to infinity, that will give us what? 1 minus 1 over infinity. And anything, a reciprocal infinity of infinity is 0. So 1 minus 0, that's 1. So using that method for the same one, in the next one, limit x tends to infinity over x plus 1 over x. That's the same thing as what? Limit as x tends to infinity of x all over x plus 1 all over x. So, just the way you have done the first one. So that would be what? Limit as x tends to infinity of 1 plus 1 over x. So which is going to be what? 1 plus 1 over infinity. And that's 1 plus 0, which is equals to 1. So if we see that the limit of both bounds is 1. The limit of both bounds is 1. So invariably, it means that x plus sine x all over x is bounded by 1. So therefore, we conclude that. Now, therefore, Now we conclude that since x plus sine x all over x is, bounded by 1, therefore the limit as s tends to infinity of x plus sine x all over x is 1. So the answer is 1. It's as simple as that. So let's go to the next question. Let's move to the next question. Now the next question is about the range and domain of okay, let's look at the next question. Let's use this. Sketch, that's number 3, or call it an example, it's 3 or question 3. Sketch the graph of the following function and states its domain and range if f of x is equal to root x plus 1. Now, if f of x is equal to root x plus 1, how do we go about this? 1. If you look at this particular value, you will say that this graph is clearly talking about square root function. It's talking about square root function. Okay, you can see we have the square root of x plus 1. And really, for real value function, this square root x plus 1 must not be negative. For real value function, it must be positive. Okay? Since x plus 1 must be greater than or equal to 0, it must be positive. It could be 0, it could be more than. So that means that this implies that x is greater than or equals to minus 1. For real. That is it. For real. So x greater than. Clearly, the domain df will now be, it's minus 1. Minus 1 is involved there. So that is going to be minus 1 infinity, because it is greater than or equal to minus 1. So it starts with minus 1. It moves positively. Now, the range RF will be, if you put minus 1 here, start with 0. That will be what? 0 towards infinity. See, I didn't close my infinity because it is an indefinite value. So that is the domain and range of the function. Now, how do we now plot the graph? Let's have something like this. Remember, our x is moving from minus 1. This is x negative, x positive. This is y positive, y negative. So, and you know that if x, because the domain of a function is set of x value, if it moves from minus 1, you could equally have 0. It's moving, it's increasing. So if x is now 0, by the time we put 0 here, 0 plus 1 is y will be what? Y will be 1. So we could have 1 as the maximum value here. Yes. So that means our graph will now be like this. It will be like this. So that is the way the graph will be. That's the way the graph will be. So let's go to example 4. Example 4. What does that say? Evaluate. Example 4. Evaluate evaluate limit as x tends to 25 of the square root of x all over minus 5 all over 25 minus x. Beautiful. Now, to solve this, let's apply 25 as x. We have what? The square root of 25, then minus 5 all over 25 minus 25. That's the meaning. Don't forget, you are not subtracting this 5 from root 25. 5 is separated from the sword here. So root 25 is different from this 5. Okay. Now, root 25 will be what? 5 minus 5 all over 25 minus 5 is 0. This is 0 all over 0, which is undefined. Beautiful. Since this result, it's a rational function that exists in form of a fraction. We have done something like this in our previous video. Now, we have to apply what we call L'Hospital's rule. Since we are getting 0 over 0, now we apply L'Hospital's rule. L'Hospital's rule that says that you differentiate both numerator and denominator of the expression to get the limits of the value that I have to find. So that means that this thing cannot be written as lim x tends to 25 of x raised power half, because if you want to write root x in this index form, this root stands as the index for the x, 1 over 2. It's standing in place of root sign. Then minus 5 all over 25 minus x. So let's differentiate x raised by half. That is half times 1 here. We have half, then x. Now subtract 1 from half, minus half. Then minus 0, because 5 is a constant, all over 25 is a constant. That's 0 minus 1. So that will give us what? This will give us half x raised by minus half all over minus 1. Okay? So minus can go up and have minus half x raised by minus half. So we can write it as minus half multiplied by this 1 over this x raised by half is square root of x. Yes. I hope you understand. Minus means 1 over. When you are changing from index to fraction, that's how it will be. You can still remember that. So now we have gotten what? That we have gotten minus 1 all over 2 root x. That is what we have gotten. Now, take limit as x tends to 25 of minus 1 over 2 root x. So that will give us what? Minus 1 all over 2 root. Our x now is 25. So that will be minus 1. Let's write it here. That will be minus 1 all over 2 times 5. Because the square root of 25 is 5. That is minus 1 over 10. So the answer to this is minus 1 all over 10. The answer to that is minus 1 all over 10. Okay? That is that about that. Now let's look at another question. Let's look at another question. Okay? Now another question. This one is still very close to what we have just done. Let's call this one example 5. Let's call this one example 5. Evaluate x tends limit as x tends to 9 over 3 minus root x all over x squared minus 7x minus 18. Now, how do we go about this? Let's apply what our x tends to. Now what? Limits as okay, let's apply it. You have 3 minus root 9 all over 3 squared minus 7 times 3 minus 18. That will be 3 minus 3, because root 9 is 3, all over 9 minus 21 minus 18. This will be 0 all over 0. It is also infinity. So it means that it also follows the line of the one we have just solved. So since we have gotten undefined expression, we apply L'Hospital's rule. So by L'Hospital's rule, we differentiate the numerator and denominator. This is what? 0 minus, this one is x raised power half, just like what we just did. So that will be what? That will be half, then x raised power minus half. If you differentiate this minus is here. Then when you differentiate x raised power half, half times 1 is half, then x, then subtract 1 minus half. That's it. All over, this will be 2x minus 7, this will be 0. So that means we'll be having what? Minus half, x raised power minus half, all over 2x minus 7. I hope you understand. Fine. Let's now apply our x as x tends to 9. Let's apply our x as x tends to 9. Let's take the limits. Now limits as x tends to 9 of minus half, x is power minus half, all over 2x minus 7. Okay? That means wherever we see x, we put 9 there. Alright, let's do that. So this will be what? This will be what? Minus half times, this is what? This one originally can be written as 1 over the square root of x. That's the meaning of this one. So all over 2x minus 7. So we have, be minus 1 over 2 times 1 over root 9, all over 2 times 9 minus 7. So this one will be what? Minus 1 over 2 times 1 over 3, all over 18 minus 7. 18 minus 7, that's what? That's 11. So subtract 7 from 18. It's 2 times 9 is 18. That's 11. So this one will be what? Minus 1 all over 6 divided by 11, which is the same as minus 1 over 6 times 1 over 11. So that's what? Minus 1 over 66. So the answer is minus 1 over 66. So with this, we have come to the end of the first part of this tutorial review. So the next video, we shall continue the second part. Please don't forget, click on the notification bell so that each time I upload a video, you'll be daily notified. Thank you.